You tried but couldn't understand. So you didn't understand the question or how to get the answer. Is that so? It was the hardest paper. The ones who tried it. Okay, so methods, there are different methods. Not every teacher teach the same methods, they're different ones. The calculation part, you mean, right? Memory management, addition, memory management, right? Yeah, okay. Yes, everyone are confused. Others tried. Confusing to answer the question. Okay. The theory part or the practical part? Or if both confusing? Which was confusing? Okay, so we'll begin. We start with the MORA 2024. It's a simple question, but I just took since it's a basic. Okay, can you all see the screen? So this is the MORA paper, all right. Miss, can you give some study tips and plans? Really stressed out these days, don't know where to start. I said I'll give at the end. Let's first finish off operating system and then discuss all the study tips and plans at the end. That sounds better, right? Target is to finish off operating system essay questions. All right. Just four, like only four, right? Okay. And some tips I sent in the WhatsApp group. I hope you guys saw that. Okay, we'll move into the lesson. So before that, what is directory entry? Someone? What is directory entry in memory management? Yeah, okay, Nasrullah. I'll let you know. Don't worry. So, what is directory entry in memory management? Let's see if anyone has the answer, the proper answer. No idea. Okay. So, basics missing, is it? It is an entry used to organize files logically. Great. Good answer. Okay, in a file system, a directory entry is a data structure that stores metadata about a file. What is metadata? Data about data. So it acts as a map to help the operating system locate and manage files on a disk. So what does a directory entry contains? It consists of the file name. Example over here, it is max.py, and the starting block number, which means the address of the first data block on the disk. It contains the file size, the total space the file occupies in bytes, and the attributes like information like read only, hidden, or system file status like that. And the timestamps means when the file was created or last modified. So that is directory entry, a data structure that stores metadata about a file, and it contains the file name, the starting block number, the file size, attributes, and timestamps means when the file was created or last modified. So in this question they said, in this the last block of the file is given as -1, and the directory entry of the file contains the block number of the first block of that file, right? So the directory entry of max.py is the starting block number. So look how we will find it. So since the chain ends at the block number 102, means since they said -1 is the last one, what is the number? 102, block number 102. Then we should trace it backwards. 102 is over here. From there, 100. 100 is here. 100 to 101. 101 is over here. Then go to block number 103. Is there 103 anywhere else? Is there? Yes or no? So it's 103, the starting block. It's 103, the starting block. Yes or no? Using the -1, they have given here as the last block. So using that, I traced backwards and found the first block. And in this question, first one, they're asking what is the directory entry, isn't it? And in this question, the directory entry is the what? It is the first block of that file. So we found the first block, that is 103. So the answer for the first one is 103. Okay, 103 is the answer for the first one, right? Was that clear? It's just a simple logic, the basics. Clear, right? Good. So that was a directory entry. And they're asking what is the space allocated for max.py. Now let's move to the question. So block size of a hard disk is 4 KB, right? Below is the portion of the file allocation table of that disk at a given time. Also, the area provides the block of the file named max.py. Can you explain again first? Okay. So see here, they are saying in this question that the last block of the file is given as -1, right? So looking at the table, the chain ends at block number 102. It is why, because through the fact table, it is marked as -1, and they have said in the question that -1 is the last block. So go with the flow. -1 next to it is 102. Then over here 102. Match it with 100. 100, go and find 100 is here. Next to 100 it is 101, and 101 is over here. And you see, match it or match it. Just match it, you will get the answer. And next to 101, what is the number? 103. After this 103, anywhere else? No, right? So that is the first block, because -1 is the last block and we traced it backwards, so that is the first block, 103. And they are saying that the directory entry is the first block of the file. So and their first question is what is the directory entry? So 103 is the answer. The block number 103. Got it? Okay. So remember it after the session, do the questions again, it will be more clear. The second question is, what is the space allocated for max.py? Now, first we calculate and say how many number of blocks are there. So to calculate the total space allocated for max.py, we need to find out how many blocks the file occupies and then multiply that by the size of each block. Now, based on the file allocation table in the in the question, we follow the chain of pointers, right? So the file starts at block 103. 103 points to 101. Then 101 points to 100, points to 100. Then block number 100 points to 102. Block 102 points to -1, which shows the end of file. So when you count 103, 101, 100, 102, total you'll get how many blocks? How many blocks is this file using? 4, right? which is 103, 101, 100, 102. So it's using 4 blocks. And they are saying that the block size of a hard disk is 4 KB. They have given that in the question. So 4 blocks into 4 KB, how much is it? Number of blocks multiplied by block size. If you are, please note it down. Mention in the book or paper somewhere. MORA 2024 paper. Just put question number 8A and write the answers. A, Roman number 1, Roman number 2, Roman number 3. Do it. That's the best way. I would say you to draw this table, and get the answer, mark the answer, like arrows put in your writing book. Because some are there who haven't studied those parts. And then put Roman number 1, directory entry is 103. Roman number 2, what is the space allocated? For that, write the formula, number of blocks into block size. Number of blocks into block size. And in this question, the block size have been mentioned as 4 KB. And we found out that there are 4 blocks being used. Right? So the directory entry, we found it out. So 4 blocks into 4 KB is 16 KB. So the space allocated for max.py is 16 KB. Was that clear? Okay. I hope you all note down the answers, right? I might not write, I'll just say it out. So here it is 16 KB, right? 16 KB. Now they are saying write down a disadvantage of linked allocation that is used to allocate disk space to files. Now, what is a disadvantage of linked allocation? There are many disadvantages, but they're asking here only one. So you could say slow random access, because the system must read every block in the chain to find a specific piece of data in the middle of a file. So the answer could be slow random access. Or you could say overhead in managing links and not suitable for indexed files, and or you could say extra space for pointers. So any one of the following you could mention, right? If a single pointer in the chain gets lost, the rest of the file becomes unreachable. So this is not reliable. That is one disadvantage. That is one more disadvantage of the linked allocation. Clear? So you could just say it is slower for random access because the system must read every block in the chain to find a specific piece of data in the middle of a file. All right, I'll move on to the next question. Yeah, only this much is there. A computer system's virtual memory address space is 16 bits. Page size is 4 KB. Physical memory is 32 KB. So they are asking the size of the virtual memory based on the 16-bit address space. That is the first question. What is the size of the virtual memory, right? Now the address space is 16 bits. So how do you write the formula size equals 2 to the power 16? So you could get the answer in different ways. You can also do it like this. 2 to the power 16 bytes equals 64 KB. So 2 to the power 16, right? So, okay, 2 to the power 16, right? 2 to the power 16, how much is it? How many bytes is it? Calculate and say 2 to the power 16. How many bytes? 65,536 bytes, right? So 65,536 bytes, you divide it by 124, 1,024. Then you will get 64 KB. Why are you dividing it by 1024? Does anyone know? Why do we divide it by 1021? Sorry, 1024. Let's see. So, you know, in memory management, you need to have a knowledge of which chapter? Chapter number system, right? Isn't it? Okay, no problem. You're on time. We are just on the first question. Just yes. So 1 KB is equal to 1024 bytes. Here they have given KB, you know. If they give 1 MB, you know it is 1024 KB, right? 1 GB is 1024 MB. So here it's in bytes. Why? Because they given you KB. So be careful on that as well. Don't go and put KB, it's bytes. So 2 to the power 16 bytes is equal to 65,536 bytes. 65,536 bytes, you have to divide it by 1 KB. 1 KB, it is 100,024. When you divide it, the answer you will get it as 64 KB. So that is the size of the virtual memory. I did this one only, this question. And now I'm in the second one. Okay. Okay, yeah. And they're asking next, what is the number of pages? So we found out the size of the virtual memory, that is 64 KB. 64 KB, if you divide it by the page size which is given on the question, the size of the virtual memory divided by the page size, the answer is what? 64 KB divided by 4 KB. Answer is 16. So 16 pages. Was that clear? Right. So that's how the number of pages is 16. How many bits are needed for a page? So they are asking the page offset. When we're doing other question, I'll explain about that more in depth. So how many bits are needed for this page? How will you find out? Using the page what? Using the page what? The number of bits. Let's see who answers it correctly. How many bits are needed for a page? For a page, how many bits are needed? Using what? From the question, will you find out the answer? Will you get the answer? Using the virtual memory address bits or using the page size or the physical memory. Using the page size. So 4 KB, yes, how many bits are needed for a page? If they ask the bits number, then you should find it through the page size. So 4 KB, when you convert it into bytes in the power of 2, what is the answer? 4 KB is equal to 4096 bytes, isn't it? Now 4096 byte, how do you convert it into bits? In the power of 2, the power of 2, how do you convert it? 4096 bytes in the power of 2, what is it? 2 to the power. So there's another method also, let's see who knows that. How do you find it? Just the KB into, let's see. So this chapter you need the knowledge of the unit number 3. If you haven't studied that chapter, you might struggle a bit over in the calculation part. Does anyone know how do you convert? How do you find the power of 2? 4 KB is equal to 4096 bytes. You know that. In the power of 2, instead of finding the bytes value, 1 KB is equal to how much? 2 to the power 1 KB. I'm saying KB, 2 to the power 10, isn't it? Guys, 1 KB, I'm not saying MB or anything, note that KB is equal to 2 to the power 10. Yes, Shasta, you're correct. 2 to the power 10. So wait, I would think it's better for me to hold on. Pay attention now. I think most of you don't know. I think confused with the powers, right? Yeah. Okay, can you all see the screen? So see the conversion. Some don't know the conversion. So 1 kb in the powers of 2, how do you write it? 2 to the power, 2 to the power, guys, reply. This is an important lesson. If the MCQs, I would have excused you, but for this, reply. Ten. If that is 2 to the power, so we took 1 kb, then how about 4? 2 to the power, 2 to the power what is 4? 2, right? 2 to the power 2. So then 10 plus 2, the power of 2's, the power of 2's you add it and you will get it as 12. So the answer over here is 12 bits. 12 bits. They are asking the number of pages, sorry, how many bits are needed for a page, and using the page size we got the answer. How? Because we converted 4 kb into bytes. If it was MB, it would be 2 to the power what? It was MB 2 to the power 20, right? Good. Now was it clear, everyone? Once we got confused, how we got the answer? So the answer is 12 bits. For how many bits are needed for a page? Through the page size, we took it, we converted it, right? So remember, if it is MB 2 to the power 20, if it is, what is next? After KB, MB and all, what is next? GB, right? GB means 2 to the power 30. And the next number they are giving, if it is 4 or 8 means 2 to the power. If it is 8, 2 to the power what? To the power 3, right? Good. So I hope that was clear. All clear, right, guys? So some people in memory management, this is where they get confused. Okay, so see, good. Okay, so we are done with that question. Shall we move on to the 2022? I think that is better now. We'll do 2023. It's hard, no? The tough one. I think, yeah. What do you guys say? Wait. Okay, so I hope you can see. So 2022, they are asking what is the repeating cycle that the processor in a computer is involved in since the computer is started till it is shut down. What is the repeating cycle that the processor in a computer does since the start till the end till it shuts down? What is the repeating cycle? This is a theory question. Very easy. Let's see, everyone. I want everyone to answer. Try it. Let's see if you guys understood the theory of operating system. It could not only be related to operating system. Maybe you need to What is a repeating cycle that the processor in a computer is involved since the time of its start till its shutdowns? Hmm? Let's see. Ajmal, Nazla, Mushrifa, Abdullah answers. Let's see how many can get it right. No one. Don't know. That's so. If you don't know, you just say you don't know. But give it a try. What if they ask you the question like this? What will you do? Just look at the paper, stare it, no right? So try, give a guess. The repeating cycle is the easy, guys. You need to, haven't you guys studied? The fetch, decode, execute cycle or the fetch, execute cycle. Got it? Remember that cycle, the fetch, decode, execute cycle. Only one got the answer. Others, or you could say it as a fetch, execute cycle also. Both ways are okay. So see, we have tested theory in essay part also. Last year, every time they test a question in operating system, right? I've said this many times. But last year, did they test in the essay part? No, right? In the 2025 paper, they didn't ask. They didn't test in the essay part. But it was there in the structure. So see, instead there was an HTML question. Your paper, we can't predict how it would be. Structure change, maybe. That's why study well. Okay, the theories. So second one, which program's instruction gets executed in the processor of a computer during a context switch? Which program's instruction would it get executed when context switching is happening? The instructions of the what? Process state? No. Which program's instruction gets executed in the processor of a computer during a context switch? I want everyone to answer this question. So this is a question where most get the answer wrong. They get it wrong. So this 2023, I would say, was one of the toughest paper in ICT. That's why I took it first. 2022, I think you guys can do that on your own. Now, what is context switching? When your computer switches from one task to another, that is a context switch. The apps themselves cannot handle this switch because they don't have control over other apps. So then what takes over? What takes over? What program instructions get executed when that context switching is happening? Operating system. All of you are wrong. Okay, all of you are strong. See, it's a, this was one of the toughest paper 2023. So do that. Do this paper again and again. The answer is operating system. The operating system takes over. It saves the state of the first app and loads the state of the second. Therefore, the CPU is executing the operating system's kernel instruction during that gap. Was that clear? Now, when your computer switches from one task to another, like Chrome to YouTube, something, that is a context switch, right? The apps themselves cannot handle this switch because they don't have control over other apps. Then the operating system takes over. It saves the state of the first step and loads the state of the second. Therefore, the CPU is executing the operating system's kernel instructions during that gap. All clear now? So if you ask what is kernel, it is the heart of an operating system, like that we would say. Sorry, hold on. So what is the kernel? It is a computer program that acts as the primary interface between the computer's hardware and its processes. So it stays in the computer's memory, the RAM, the entire time the computer is on. So in memory, I'll explain that what kernel does. Listen to it carefully. They could test a theory question on it. Note on what, Mushifa? The kernel. What the kernel does, is that so? You're asking. What note are you asking on? Okay. So wait. First listen what kernel does. Okay, what is kernel? Okay, so it is like the heart of an operating system. So it is a program that acts as the primary interface between the computer's hardware and its processes. So it is a program. Read the question: which program's instruction gets executed in the processor of a computer? So in kernel, it is a program that acts as the interface, the primary interface between the computer's hardware and its process. So it stays in the computer's memory, means the RAM, the entire time the system is on. So it does four things in different ways. So in memory management, the kernel keeps track of how much memory is being used and by whom. Whereas in process management, it decides which program gets to use the processor, the CPU, and for how long. So the kernel only decides which program gets to use the processor and for how long. And what is the question asking? Which program's instructions get executed during a context switch? So it is the operating system's kernel instructions. Got it now? Was that clear? So in process management, the kernel decides which programs gets to use the processor and for how long. In memory management, it keeps track of how much memory is being used and by whom. Now, was that clear? Was it clear? The operating system's kernel instruction, you could say, or just put operating system also, the answer is correct. In the marking scheme, the answer was operating system. So the answer is operating system. In the official scheme also, they said operating system only. Check that also. First one, it was fetch, execute, cycle, fetch, decode, execute, cycle, something. And second one is the operating system. Now, when a context switch happens, the kernel is the part of the operating system that steps in. What does it do? It pauses one program, saves its progress, and starts the next one. This is why the instructions being executed during that switch belong to the operating system kernel. So remember the theory part of the kernel as well. No, there are no alternative answers because operating system is the one that does it, right? There cannot be any alternative answers. All clear, right? So next one, a register is a group of binary cells suitable for holding binary information in is. So this is about register flip-flops. They are asking how many flip-flops are needed to make an n-bit register. What do you think is the answer? The answer is there in the question. How many flip-flops are needed to make an n-bit register? I want everyone to answer. So what is register? It is the faster type of memory located right inside the CPU, right? And this computer thinks in binary means ones and zeros. That's what they are saying, a group of binary cells, right? So a flip-flop is a tiny electronic circuit that can hold exactly one bit, a zero or a one, like that. Now to hold a n bit of number, you simply need n of those circuits lined up. So the answer is just n. Exactly, Ajmal. So they're saying n, so it's n. That's it. Correct. So this paper was a bit tricky, right? There are more questions. Now, a user runs the following Python code on a computer. The code on left prints the lines of a file on the screen while the other does an average computation. Now the computer's memory at a particular time is shown at 10, this figure, okay. The memory frames occupied by the operating system, the file reader process, the average process are indicated on it by OS, AP, FP respectively. Selecting from OS, AP and FP, write down the most likely place where each of the following is stored. So this is something where Python is also connected. Now they are asking to select from these three and write down the most likely place where each of the following is stored, where the following are stored in. Content of variable A of the file reader process. So in file reader process, you're getting an input, you're opening it, reading it, and you're printing it, and then you're closing the file, right? So what is the content of variable A of the file reader process? What is it? You're getting the input, means you're entering the file name. Where do you think would this be stored in? In the file reader process, the average process, or the operating system? Content of variable A of the file reader process will be stored in FP itself, the file reader process. This is stored within the process own memory space. Simple, right? I don't have explain. Sorry, I don't have explain that in deep, right? The PCB of the average process. Where is it stored? Now, the PCB of a process. Where do they store it? In that relevant process itself, in AP or where? What are PCBs? PCBs are the data structures managed and stored by what? By the operating system in, again, kernel memory, right? Kernel memory comes in between. So the answer is operating system. Very good. All are correct. So all clear, right? I don't explain more in depth because you know what is PCB and all. It is a data structure, right? Okay. Of the above two Python processes, one of them will go through the running to block state transition more than the other. Which process is that, and give the reason for it? Now, which process is going to running to block state transition? Who can say the answer? Which process it is going from running to block? You mean B question, which part? Third question, third is, I'm doing C, right? Third is C, right? Are you saying B question, Roman number 1 or Roman number 2, Harishni? Ajmal wrong. Not the average process. Read properly. Harishni, dear, which one can you? Mustafa, what is the question? What is the answer? Which of the above two Python processes, one of them will go under running into block state transition more than the other one. Which process is that they ask? Is it the file reader or the average.py process they ask? And if you're giving as average y, if you're giving as file reader process y. So first you have to find out which one of them goes to running to block. Your answer is not related to this. Confused, right? It is the file reader process. The file reader process is the one most likely to transition from running to block. And why? Because the process performs input-output operation, means reading a file which are slow compared to CPU speed, causing it to block while waiting for data from the disk. Was that clear? Why is the answer file reader process? Because the process is waiting for input output operations. Example, reading a file, right? C input, R is what? Reading, which is slow compared to the CPU speed. Because of that, it would be blocked while waiting for data from the disk. Now was that clear? Ajmal, Mushrifa, Harishni, all clear? Even if you got it wrong at the first attempt, don't worry. Because this question, many got confused. So they are asking which one will go from running to ready block transition, right? State transition. It is the file reader process. Why? Because this process is performing input output operation like reading a file. See, if you know Python, you would understand. See, it is doing input output operations, isn't it? This process performs input-output operations which are slow compared to the CPU speed. So it gets slowed down, it gets slow, right, comparing to the CPU speed, because if you are waiting for input and output operation, it gets slower, causing it to block while waiting for data from the disk. So when it gets slow, what will happen? It will get blocked when you are waiting for data. When it is waiting for, when the process is waiting for data from the disk, it will get blocked. So that's why it's running to ready. As there is file reading in it. Remember, just the answer. So we're asking which process is that. Put file reader and they're asking give the reason for it. Under it you can just write as there is file reading in it. Simple. The explanation I gave was in depth, but you can write it as there is file reading in it. Even in the past paper, official scheme of real like that, right? I think. Again, yeah, you could say has there is file reading in it, or you could say has it is involved in input output like that, or because it has to wait for input, right? See, you're getting an input, right? You know Python, you might understand. I hope you have said Python. Clear now, everyone. Since it's getting input, it gets slower down. Yes, yes, good. Okay, I don't know if we will be able to finish off entire pay, but I will try to do the 2023 and 2024. It's 23, right? 2022, we'll see another day. Okay, hopefully. And guys, if I'm unable to give the study tips today, I will drop in the WhatsApp. Read it carefully. Okay. A study tip. Study plan. I think it will be better to give on another day. Okay, so I will move on to the questions at this time. Assume that when the file reader process of B above is in a progress, a context switch occurs and a different process is run. While the file reader process is given the chance to run again, the file is read from where it is stopped. Which data structure facilitates that feature? Very easy question, isn't it? If a context switch occurs while the file reader process, see about file reader, right? While the file reader process is running, the context switch is happening. So what helps? Which data structure facilitates this feature? The context switching, remember, see, they are saying about context switching. Read it. Even though there were some tricky questions, there were some direct theory questions, but people still messed up. Correct. Good, I'm getting answers. Yes, all correct. PCB. PCB of the file reader process. You cannot write only PCB, that would be wrong. They have, like the marking scheme also, they said if you write only PCB, it's wrong. You have to say, since they are mentioning over here the file reader process, right? Write it as PCB of the file reader process. If you are not writing answer now, no problem. Get the recording, watch it again, and at least write the proper answer. Because in ICT, even though the answers are small and direct, there are chances where they would deduct your marks. If you put just PCB, no marks. So see, be careful. Okay. That's why I would say ICT, take the official marking scheme PDF and check it. The answer scheme. Don't go and check from some publications, they give the wrong schemes actually, the wrong allocation. Wrong answers also could be there. So check for the official PDFs, official files, right? So that was clear. No? A computer uses 32-bit virtual address. This computer has 1 GB, means see 1 GB they had given over here, it's 232 to the power 30 bytes physical memory and a 4 KB file size. Write down the number of frames in physical memory has a power of 2. Now simply you could say it as 1 GB they have already converted to and given to you it in powers 2 to the 30. What is the page size? 4 KB. Now I already did, so I'm not going to do it again. 4 KB, when we convert it into power of 2, what is it? 2 to the power? 2 to the power? Resend the first name recording link in group. Okay, sure. Operating system CQs, that is, I will send. 2 to the power 12. 4 KB, when we convert it is 2 to the power 12. So this one they are given. 2 to the power 30 divided by 2 to the power 12. Don't go and do it actually. Not like that, I was just saying. 2 to the power 30, 2 to the power minus 2 to the power 12. So what you have to mind deduct over here is 30, the powers. Over here the power is 30. Over here for this 4 KB it is 2 to the power 12. So 30 minus 12, the answer is what? 80. So the number of frames in physical memory as the power of 2 is 2 to the power 80. Simple. I don't have to write and show, right? So 2 to the power 18 is the number of frames in physical memory as the power of 2. Clear? Clear? So the computer has a 1 GB physical memory. So physical memory and the page size, I got both of them in the powers of 2. And the power of 2, the number 30, 30 above the 2, that one only I deducted. 30 minus 4 KB, I have to convert it, right? I converted and got 2 to the power 12. So 2 to the power 30 minus 2 to the power 12, the answer is 2 to the power 18. 30 minus 12 is 18. So the answer is 2 to the power 18 for the first one. That's how you find the number of frames. Physical memory minus page size. Okay. So next one. Assume that in addition to memory frame information, each page table entry for a virtual memory in this computer contains some additional information of a total of 4 bits. Okay. If the total size of the page required for each processor on this computer, assuming that all virtual pages are in the use, is given as 2 to the power p and multiplied by q bits, write the values of p and q. So they are asking the value of 2 to the power p and multiplied by the number of bits. Now each page table entry of a virtual memory, it consists some additional information, and that additional information, it takes total of 4 bits. Now earlier, what is the number of frames we got in the power of 2 to the power 18? Right? 18 plus 22. See, 18 plus 4, I said the answer in English is 22. So 22 is the number of bits which I said now. Then what is P? P is what? So they are saying if the total size of the page table required for each process on this computer, assuming that all virtual pages are in use, is given as 2 to the power b and q bits. Okay, so it's per entry they are asking. Now see the virtual address space they are given over here. 32 bit, right? So P, what they are asking is the number of pages. Remember, P, they are asking the number of pages. How do you find the number of pages? What is the virtual address space they are given here? 32. So 2 to the power, they are saying in bits, right? Take it into bytes. 2 to the power 32 bytes. 2 to the power 32 minus 2 to the power 12, the page size, virtual address minus page size. I said, remember, in the powers of 2. So 2 to the power 32 bytes minus 2 to the power 12, you will get as 2 to the power 20. So the power 20, the 20 is the number of pages. Hold on, I'll take that PDF. Hold on, this is getting stuck. So how do you find the number of pages? We did the question earlier. They are given the virtual address. Can you see? So this is question number E, right? Yeah, E. It is Roman number 2. All right. So now to find the where they are asking p to the power 2 to the power p. So they are asking the number of pages. So they have given the virtual address space. See the question. I hope you can see it is 32-bit virtual address. 32-bit, when you take it to the power of 2 the bytes, it is 2 to the power 32. So, okay, 32. And then they are saying, and then we have to take what? The page size. 4 KB into the power 2 to the, in 2 to the power, I mean the power of 2. 4 KB in power of 2, it is 2 to the power 12. We did the calculation earlier, right? See, 12 bits. 4 KB converted. So what is the answer? 2 to the power 20. Simply, they are asking over here the power, right? See, so see carefully, they are giving the question, they are asking P, 2 to the power P. In the question, they are asking only P. They didn't say to write with 2. So put the answer as P equal 20. Don't go and write in the powers of 2. P equal 20, since they didn't ask that in the question like that. And then next they are saying what? Q. So this bits per entry. So each entry needs to show the frame number. So frame number, how many bits we calculated earlier? In Roman number 1, it was 8, 18 bits, 2 to the power 18, isn't it? Frame number. So each entry needs to show the frame number, which is 18 bits. And they are given in the question that for additional information, it consists a total of 4 bits, isn't it? Right? So 18 plus 4, the answer is, what is the answer? 18 plus 4. Answer is 22. So Q is 22. Simple. So what is this? The total size in bits and the number of pages. Number of pages multiplied by the size of bits, you will get that the total size of the page table required for each process. Got it? Clear? So 2 to the power PQ multiplied by 22. That's all. You don't need to do that here. Yeah, right? And then next we have is the Roman number 3, right? If the virtual address 4097 of a particular process is mapped to frame number 2 of physical memory, write down in decimal form the physical address corresponding to the virtual address 4097. And they're saying to assume that page numbers, frame numbers, and addresses begin from 0. So virtual address, they are given it as 4097. So what is the page number? Now 2 to the power 20, okay? Okay, sorry for that. A virtual address of, sorry, physical address for virtual address 4097 is mapped to frame number 2. So the page number is 4097. When you, that's this, divided by 4096. Our reminder is 1. So I will do this in binary format, then you guys will get it. So you might know what is offset and all. So over here, page number is 1, then the offset is 0, 0, 0, 0. Sorry, 1. If it is frame number 2, they're saying about frame number 2. So the binary in binary of 2, how do you write? As this way, isn't it? 12 is the offset bit, 12 sets. So yeah, see 12 bits. Where's the page number size? 4 KB, yeah. So virtual memory is there, 12 bits. So that is the offset. It is a long way, actually. So explain another way. I don't know if you guys will get it. Let's see. 2 seconds. When you convert it into decimal, the answer would be actually 8,000, yeah, 8,190. Now to calculate physical address, we need the frame number, the frame and the frame size and the offset. So frame number they have said over here, the question is 2, isn't it? And the frame size is 4096. Frame size is 4096. So I'm putting it as PA, which is a physical address. To get it, we need this formula. So see the formula, right? Frame number into frame size plus the offset. So over here, frame number they have said it is 2 and the frame size is 4090, yeah, 96. 4096 minus 1 is 4096. And then you have to add the number of offset. Offset, how do you go to page Okay. Sorry for that. Sorry for that. We'll get quickly finish this off. Connection issue. All clear. Can you see? Can you see? Now see. 4097, this is the virtual address they have given that in the question. That you have to the virtual address divide by the page size, you will get the page number. What is the page size in the question? 4 KB. 4 KB into bytes is 4096. That's why I put 4096. So when you divide 4097 by 4096, you will get 1 as the remainder, isn't it? So page number is 1. How do you get the page number? How do you get it? Page number, virtual address divided by the page size. Virtual address they are given in the question. Page size also they have given it as 4 KB. You have to convert it into bytes, and that you have to do the modulation, right? Modular. Then you will get the remainder as 1. So that is the page number. That is the offset. You could say it as, wait. And they are asking the physical address. The physical address, to get it, you have to get the frame number, frame size, and the offset. So remember this formula for the total. Wait, I'll give you at the end itself. I think I should make a formula sheet first of all for you guys. Now we found the page number is 1, the offset is 1, right? What you have to do is multiply the frame number by the page size. What is the page size? I would say don't see this method, it's very confused. What is the page size, guys? The page size 4 KB converted into bytes, it is 4096. So 4096, you have to multiply it by the frame number. In the question, what have they given as a frame number? See, number frame 2. 2 into 4096, the answer is 8192. Clear? Frame number multiplied by the page size. Okay, 4096. Isn't it? Answer is 8090. But is this the correct answer? No. Why? Because you have to add the offset. So the earlier I gave a formula, that is only this one. In a different way I given. Plus 1, the answer is. So this is the answer. 8093 is the. What is the physical address corresponding to the virtual address? Clear? The conversion a bit confused, right? So the formula, I think it's better if I make a poster and send like. Clear now, guys, everything? Yes, good. Do the questions again on your own. If again you get confused, you can, drop me WhatsApp message, I'll clear it. Clear, right? So 4 KB if we convert it, okay, then conversion is only the whole thing about this lesson. So next one, the test.py file is stored on blocks 218, 220 respectively in a disk that uses a file allocation table to manage its store. The disk uses 4 KB blocks. Write down an important number in the directory entry of the test.py file that will help the OS to find the block of the file. Now write down an important number in the directory entry for the test.py file that will help the operating system to find the block of the file. What is the directory entry of this? Answer. Directory entry. Very easy. Read the question. What is the directory entry? To help the operating system find the blocks of the file, the starting number is the most important piece. And it is stored in the directory entry. The value they are given over here is 218. So that is the answer. That is the directory entry, 218. Okay. Right? Given example size for test.py that will result in internal fragmentation. So what is internal fragmentation? When the last allocated block is not completely filled by the file data. Example size for test.py, you can take any size between 4 to 8 KB. 4 to 8 KB. The disk uses 4 KB, right? So any size that is not a multiple of the block size will result in internal fragmentation. For instance, a file size of 5 KB, which is 5120 bytes, would use one full block and leave the second block partially empty. So here they are asking what internal fragmentation. You know what is internal fragmentation? It occurs when the last allocated block is not completely filled by the file data. So the answer for this question is 5 KB, or you could say, any size that is not a multiple of the block size. So 5 KB or 6 KB or 7 KB. Any three of this is the answer. So you can just write it as 5 KB. Let's say that's the answer. That's it. Clear? So any size between 4 to 8 KB is the answer. I mean, you can put it as 5 KB is the 8 KB something. Yes, clear, right? Good. And then we have assume that the block 219 is also going to be added for the tester. So already they have already these two, right? Show in a diagram that the fact entries of the test.py file after this addition. So the last block. Now early in the question we got -1. Remember, -1 was the last block. So here also -1 is the last block. How are we going to draw is 218 they have given as the first file. What is the first file in this question? They are given 218. 218 after the 220. So 220 I am matching it to 19. And 219 is the last block, isn't it? The end of the file. So that is -1. You have to draw this in a table form, okay? Was that clear? And the order is must. 218 is the first one. You match it with 220, which is the next box they are given. After 220, you have to match it to the last box they are given. That is 219. 219 is the end, right, of end of the file. So end you have to indicate how? In -1. The last block. Clear now? So the pointer -1 indicates the end of the chain. So write this in order. If not, they would not mark it correct. Everyone clear? Okay. So 2024, shall we discuss on another day? Next session will be on net subnet. No, see, not subnet. On submitting. What do you all say? Next question. Sorry, next session. Was I fast or slow? Guys, like today all of you are a bit active actually. I'm happy to see that. Not normal, good. I think it's enough for today now. We don't have to drag the session like last. Your face was easy to understand. Miss. Okay, that means a lot. I didn't want students to feel overwhelmed actually. Last session I did 3 hours for the MCQ discussions. I think around 50 MCQ something. And I got some messages saying that it was good. The session was really good, but for them 3 hours were like too much in one day to discuss. I know past papers are very tiring, but my past paper program will be in a different way. Okay, I think it's enough for today, right? Enough, no? So we discussed the 2023. I didn't think it would take too long. There were so many basic questions coming up also. So yeah, but it's okay. I'm happy that I cleared out your basics also, even though it was a simple questions. Okay. That's what I conduct these sessions, right, to help you guys with even the basics. Thanks a lot, Miss. I understood your explanations clearly, even if I didn't have much knowledge in this session. Okay, that means a lot to me, Harishni. Next class also on Thursday, maybe on a Tuesday or else a Saturday morning. You know, you should pay for discussions on Saturday mornings. So next session will not be next week, the after that week. Okay, so you know, I am having a very hectic schedule. I'm doing a fast paper program. If you feel like you need to join, no problem. This one I thought to do because many requested also for me to conduct paper 2 discussions. The ones who requested are unable to join live, but it's okay. They are at least getting the recording and joining, and that means a lot. I think last session also early few joined live, but more than 30 got the recordings, I think. Yeah. And I got a lot of feedbacks. I was happy to see that. That's what makes me motivated to do more free sessions. If not, I would feel like no one is getting the benefit from it. If I know students are getting benefit only, I'll do more, right? That's right. So I'll drop another form today also for this session. I think it's enough now for today. We go more further to the 2024, it will take more longer. Welcome, Shazna. Thank you. Okay, so let's end it today. And yeah, study plan, study tips. I will drop it in the WhatsApp message. Like, how to study theory, something like that. Instead of rereading your notes, what to do, I will say something like that. Don't read your notes again and again. If you are done with the syllabus, and if you haven't done like that, also I would give. And suppose if I haven't didn't drop a message and you feel like you urgently need help, drop me WhatsApp message directly. I will help you out. Okay. Ajmal, all good. You guys are really active today. I'm so happy to see that actually. So that's why when you guys are being active, the session went a bit fast, the last session, isn't it? You were active, responding, so the sessions went on a bit faster because of that. Good. Welcome. I hope you learned something new today. It was all clear for you and then everything. Okay, so see in next session. Hopefully it will be Unit 6 MCQs. I haven't decided if I should do theory MCQs or subnetting. We'll see. I thought to conduct on subnetting since many had issues on that. If not, we'll discuss the theory MCQs also together. We'll see. A mix. But that will be on MORA papers and FWC because past if I'm doing a separate program. No. So this one I did as a request also. I wanted like many had trouble. Okay, thank you for joining in. Yeah, so I'll send the form. Bye. Any issues, drop me WhatsApp message. And Mushifa, really active guy. Unit 5 exam is also there, right?